This is problem 11 of the 2022 MMATHS Individual Round, and the problem reads, denote by real part of z and imaginary part of z, the real part and imaginary part respectively, of a complex number z. That is, if z equals a plus bi, then real part of z is equal to a and imaginary part of z equals to b. Suppose that there exists some real number k such that the imaginary part of 1 over w is equal to the imaginary part of k over w squared, which is equal to the imaginary part of k over w cubed, for some complex number w, where the magnitude of w is square root of 3 over 2, the real part of w is greater than 0, and the imaginary part of w is not equal to 0. If k can be expressed as root a minus b over c, for integers a, b, and c with a square free, find a plus b plus c. All right, so there seems to be a lot to unpack in this problem. And first, it would be helpful if we wrote w as part of the as in the following form, where we write w is equal to m plus ni. And this will be helpful because the real part of w will be m, and the imaginary part of w will be n. What does it mean for the magnitude of w to be root 3 over 2? Well, the magnitude is just the length or the distance from w to the origin in the complex plane, because if you recall, the complex plane looks something like the xy plane, except for this is the real axis and this is the imaginary axis. And the point m plus ni could be plotted about right here, where the real part is m and the imaginary part is n. And thus the distance from 0 to m plus ni is, using the Pythagorean theorem, square root of m squared plus n squared. So for the magnitude of w to be equal to root 3 over 2, we must have root 3 over 2 equals square root of m squared plus n squared, which in turn implies 3 over 4 equals m squared plus n squared. Okay, so that's helpful and all. But what do we do about this new equality, namely the imaginary part of 1 over w is equal to the imaginary part of k over w squared, which is equal to the imaginary part of k over w cubed? Well, in order to sort of use this equation, we need to specify an identity. And namely, that identity is going to be as follows. We have w times w bar, and I'll explain what w bar is in a second, is equal to the magnitude of w squared. And this w bar, we say, is the conjugate of w, and it's basically m minus ni. And if you were to actually multiply m minus ni by m plus ni, you would get something like m squared plus mni minus mni minus ni squared. But this mni and the negative mni would cancel out, leaving you with m squared minus ni squared. But if you recall that I squared is -1, then the minus sign turns into a plus sign. So you get m squared plus n squared, which conveniently is what this guy squared is. Okay, so that is the identity that we're going to use to make this guy look a lot nicer. And in particular, 1 over w equals w bar over magnitude of w squared. That's a direct application of this if we rewrite it. However, we see that the magnitude of w squared is nothing else but this guy squared, which is 3/4. So we write this as 3/4. Okay. This is, and then we look at k over w squared, And once again, by direct application of this guy, this is equal to w bar squared over magnitude of w to the power of 4. Magnitude of w is root 3 over 2. And if you fourth power that, you get 9 over 16. And finally, k over w cubed is equal to w bar cubed over the magnitude of w to the power of 6. However, once again, the magnitude of w is root 3 over 2. And if you take that to the 6th power, you get 27 over 64. And of course, these two have to be multiplied by k. Okay? But now what we need to do is we need to look at the imaginary parts of these three guys, because the imaginary parts of these three quantities, they're all equal to each other. However, we know that w equals m plus ni, so w bar is equal to m minus ni, like we already specified. W bar equals m minus ni. So this guy turns into m minus ni, and then you divide that by 3/4, so you're effectively multiplying this by 4/3. This guy turns into 16 over 9 k times m minus ni squared. And if you expand that out, you get m squared plus n squared minus 2mni. Okay? Finally, this guy over here turns into 64 over 27k times w bar cubed. And if you expand w bar cubed out, you will get m cubed minus 3m squared ni minus 3m n squared plus n cubed I. Now, that's all well and good. We only care about the imaginary parts of these three guys. And what the imaginary part is anything that is multiplied by I. So this first guy would have imaginary part negative 4/3 n. This guy would have imaginary parts negative 32 over 9 k m n. And this guy, well, it has an imaginary part of 64 over 27 k times the quantity negative 3 m n m squared n plus n cubed. Okay, and all we care about are that these pink parts are all equal to each other. Okay, so let me clear out some more space, and we're going to say that these three pink numbers are equal to each other. Okay, but what does that tell you? It tells us that these two are equal to each other. So I could simplify this a little bit by saying negative 4/3 n equals negative 32 9ths k m n, and you can get rid of the n from both sides, multiply by both sides by 3, divide both sides by negative 4. This becomes an 8, this becomes a 1. Or alternatively, 3/8 is equal to km. Okay? We also have these two guys are equal to each other, which is convenient because we can simplify that a lot. 32 over 9 kmn equals to 64 over 27 k times negative 3m squared n plus n cubed. And once again, we can cancel some stuff out. We can get rid of the k from both sides, multiply both sides by 9, divide both sides by 32. So this becomes a negative sign, this becomes a 2. Divide both sides by n, so get rid of this, and this becomes an n squared from n cubed. Okay, so we have this equality. Now I'm going to strategically get rid of some of this other stuff and circle the important stuff in this nice blue color. This guy, and this guy. And look what we have. We have 3 equations and 3 unknowns, k, m, and n. And this actually becomes very nice to solve. What we do is, well, we say, okay, let's rearrange this guy so that 3/4 minus m squared equals n squared. And we plug that back into this. So I have negative m equals 2/3 times negative 3m squared plus n squared, and n squared is 3/4 minus m squared. All right. And then we say, well, negative m is equal to 2 over 3 times negative 4m squared plus 3/4. Okay. And after that, what do we say? Well, let me make some space for myself by writing the km closer over here. after that, what can we say? We can actually just solve for m right now. So m, let's multiply everything by 12, or I'll say 6 to make things easier for ourselves. So negative 6m is equal to negative 16m squared plus 3. Okay. And that's extremely nice because now we can solve for m. We have, by rearranging this, 16m squared minus 6m minus 3 is equal to 0. Quadratic formula will give us m equals to 6 plus or minus the square root of 6 squared minus 4 times 16 times negative 3 all over 32, 2 times 16. This is equal to 3 over 16 plus or minus the square root of 57 over 16. All right. And so what does that tell us? It just tells us that m is equal to this. But as we know, we only want one solution to m because we want to be able to figure out what m is. However, the problem here is that, well, there are two values of m, but luckily we have this condition, the real part of w, which is m, is greater than 0. And we see that over two solutions, 3 minus root 57 over 16 is negative, which means that we can discard it. Okay? And what that means is that m is equal to 3 over 16 plus root 57 over 16. Now, how does that help us? Because remember, we're looking for k. Well, we have this one last equation that we haven't used. 3/8 is equal to k times m. And given that m is equal to this stuff, we can actually say that k is equal to 3 over 8m. That is to say, 3 over 3 halves plus root 57 over 2. And this is equal to 6 over 3 plus root 57. Now, in order to simplify this so that it fits this form right here, we will multiply both the numerator and the denominator by 1. By root 57 over 3 over root 57 minus 3. And then the numerator becomes 6 times the quantity root 57 minus 3. Denominator becomes 48. And so when you cancel out, 6 over 48 turns into 1/8. And you get your final solution is root 57 minus 3 over 8. You want to find a plus b plus c. That's 57 plus 3 plus 8. And this is equal to 68. And we are done. Thanks for watching, and I will see you next time.